Alright, we're going to go over what we did in class today, constructing a hexagon inscribed in a circle. The process is going to be to first draw a circle with your compass. So I'm going to draw, create, construct a circle. Always label your center point. It's going to be helpful. And now we're going to go on the edge of the circle. We want to cut, a hexagon is a six-sided figure. And this is a regular hexagon that we are constructing. It's a six-sided figure. And we went over in class a little bit more detail. I'm just pretty much going to do the construction here. So you go wherever you start. It doesn't matter where you start on the circle. You have to keep the radius the same as your original circle, and you have to go somewhere and start making marks. Once you make your first mark, you just go to that mark and you continue to make marks all the way around. Alright, so I'm going to go ahead and do that. We could make the entire circle with these marks, but I don't know why I'm doing that. It's getting late, getting a little tired here. It's not that late, but I'm still tired. Alright, so go up here and do this. And if you have a compass at your house, be a good thing to practice. And if you did it correctly, if you're careful, which sometimes I'm not, your next mark should land right on your first mark. Alright, so now you have 6 intersection points. So I'm going to take these points, I'm going to mark them like this. You want to connect the points that they intersected on the circle. So I'm actually going to remove now these blue marks. Blue little arcs, mini arcs that I created. And what I've done at this point is divided this circle's circumference into 6 equal parts. So from here, we can just connect these points. Remember, with the equilateral triangle, we connected every other point because we want 3 sides. Here we want 6 sides, so we can just connect all of these points. Alright, and that is a hexagon, a regular hexagon. And we also talked about how the interior angles in the hexagon are all 120 degrees, each one of them. 120, 120, I'm not going to label them all, but they are all 120. And the sum of all of them is 720 degrees if you add up these 6 interior angles. They are all 120 degrees and they add up to 720. Alright, so that is a regular hexagon. Okay, I don't ever think I put up a video on creating a 90-degree angle, so I'm going to go ahead and throw it on this one that has the hexagon and some other things I'm going to do, like the answer to the extra credit. But if I wanted to create a 45-degree angle, that's what I want to create. Well, to create a 30-degree angle, we use the fact that we know about equilateral triangles that you have a 60-degree angle, 3 60-degree angles in a triangle, in an equilateral triangle rather. And we bisected one of those angles to create a 30-degree angle. So if I want to create a 45-degree angle, it'd be a good thing to create a 90-degree angle and then split that in half, which would give me 2 45-degree angles. So think to yourself, what did we use, what did we have, or what constructions have we done that included a 90-degree angle? Well, remember when we did the perpendicular bisector? That always created a 90-degree angle. And we know that because of the term perpendicular. That means when two lines are perpendicular to one another, they create a 90-degree angle. So if we do the perpendicular bisector, which I'm doing, which should be review. I know some people were not here for the 90-degree angle, and I said I'd put up a video, and I never did. So here it is. So I'm going to do my line, which is, okay, that's the perpendicular bisector. Now what I have is a 90-degree angle. So now I can go ahead, bisect this angle. Remember to bisect, we're just going to do an arc. Remember, each one of these is 90 degrees, so I'm going to go like this, and then go up here, and make another arc, and go down here, make another arc, alright, and then I'm going to make my ray right through there, through the intersection, right there. Alright, so I've now created two 45-degree angles. So this is 45 degrees, and this is 45 degrees. Alright, so that is how you create a 45-degree angle. Alright, let's take a look at the homework. We have, I have the homework sitting right here. And as I look at it, I need to find what these angles are. Some of these angles are going to ask me about. So the first angle is measure FRG. So FRG would be this particular angle right here. I'll color it in. So FRG would be right here. All right, so now, how are we going to get that? Well, we know that this entire line, if I look at this line CL, alright, I know that that entire line go like this. Remember, a line, anytime you have a line, a straight line, the sum, it's going to equal 180 degrees. So if I look at this line and I have this one being 80 degrees, this one being 40 degrees, the only way for this to be a straight line is that this angle has to add up to 180 when you add these three together. So we know that that has to be 60 degrees, FRG. So what you would do is go on the bottom, and you would put A into your 60 degrees. All right. Now we can go through this piece of information right here, AD. Remember, this upside down T means perpendicular. So AD is perpendicular to BR. That means we have two right angles. ADB we know is a right angle, and ADR or ADG, or however you want to name it, these two lines or these segments or these two rays, however you want to think about it, these are also 90 degrees. So we have 90 and 90. All right, and when you have that, it's going to help us to figure out the rest of them. Plus, they might even ask you about this one right here. So that's help on the homework. The other page of the homework is mostly vocabulary. If you don't know some of the vocabulary, I encourage you to Google it. We've talked about most of the things in there, but some of them on the homework you might not recognize. But it'd be a quick and easy thing to Google it, Google the word, see what it means. All right. Next, I'm going to talk about the extra credit assignment that I gave you. Okay. Looking at the extra credit. I had this problem on the extra credit, and I had 3 questions I asked. The first one I actually answered in class today, but if you weren't there or maybe you weren't paying attention, the first extra credit problem asked about this particular triangle. Remember, we had constructed the perpendicular bisector here, and I asked, is this triangle equilateral, yes or no? And the issue with this, you cannot just say it looks a certain way. You have to be able to prove it. So one way to prove whether it is or isn't, if we find, or if we know that we did the perpendicular bisector, then we know that this angle, which is part of our triangle, has got to be 90 degrees. So BIC, angle BIC is equal to 90 degrees. Because of that, we know that it can't be an equilateral triangle. Remember what we know about equilateral triangle. It has to be 60, 60, and 60, which this is not. So we can prove it that way, that this is not an equilateral triangle. So that's the first part. The next part was, how many squares do you see? Well, if I look here, I see one square here. I see another square here. I see another one here. That's 3. And I see 4. And I see 5. And I see 6. Now maybe you see more than I do. That's all I see at the first glance. So there's 6 squares that are that I was thinking about myself. All right. The last question, probably the trickiest one, maybe. Not that tricky. Once you actually look at the question, you'll see what I was talking about. My question was, what is the area of square ABCD in relation to square EFGH? So ABCD, so this entire square, what's the area of that in relation to square EFGH? So this entire square. So it confused a lot of students because they said, well, we don't know the area, we don't know the length of sides, a lot of stuff we don't know. But remember, area is simply how much is inside, or how much the shape covers. All right. So if I look at this particular square, A, B, C, D, well, how many triangles make up that square? Well, it looks like 1, 2, 3, and 4. And remember, all these triangles are the same. So now if I look at the bigger one, EFGH, how many triangles make up the entire square? Well, you have 2, 2, 2, 2. So you have 2, 4, 6, 8. So if the inner square, ABCD, is composed of 4, and the entire square is 8, that means that this square's area, ABCD, has got to be half of the area of the entire thing. And it wouldn't matter if I took this and I shrunk it, it's still going to be the same relationship. All right, so so let's just say, let me just make sure all these are together. Group 1, group. So if I take this, and the computer's acting kind of slow right now. See, it still didn't do it. But anyway, it wouldn't matter how big. If you did this construction, what you see right here, if I gave you the inner inscribed square versus the square that is on the outside, it's always going to be half. It's always going to be exactly half, just because of what I just told you. All right, so hopefully that answered any questions that you had about this. Some people were confused about what I was asking for. That's really what I was asking for. This square, the area is half of the bigger square. There's other ways you can look at it, but I looked at it as the whole thing is composed of 8 triangles, and then the square in the center is composed of 4 of those. So it must be half of the area.